Welcome back to this series on learning Rust. Now this episode's going to be slightly bigger than anything we've tackled before because there are three things we need in place before we can start to build our next project. We need a way to organize our code into modules, we'll need to know the standard collections for storing data, and we'll also need to know how to handle errors. We'll tackle them in that order. And if it feels like a lot, don't worry, we'll take our time going through the content so you don't need to worry. I've gone ahead and created a new project using cargo new. And the first thing we are going to tackle is modules. So as your programs grow, cramming everything into one file can get very messy very quickly. So in Rust, you split the code into modules. Now, a module is just a named container for code, and you declare one using the mod keyword. Everything inside a module is private by default, so nothing outside can see it unless you deliberately open it with the pub keyword. That default is a feature, and it means that you get to decide exactly what the outside world is allowed to touch, while everything stays a private detail that you're free to change later. Let's write one and see it in action. All right, let me open up a terminal. I'll use the same one that I was using earlier and just run it. And we can see that track started has been printed to the console. I'll get out of that and we'll walk through the code that we've just written. So we've got a module here called audio. And then inside that, we've got another module called playback. And inside that, we have a function called start track, which is printing out track started out to the console. Now you see these pub keywords that we've got here. If we were to take those off, nothing outside would be able to reach in. And the start track function would go dark. So the full path to it is essentially audio : playback : start track. What this create line is doing here, so use create audio playback, what that is doing just means that we can use the start from the root of this crate. Now, typing out the whole path every single time you call it is unnecessary, and that's the whole point of this use line. It essentially brings playback into scope. So from then on, we can just say playback : start track, and that's how we can call the method. Now, as your project gets bigger, you can split these models into their own files, and your folders end up mirroring the module tree. So module would just move into its own audio.rs. So right now we're working in the main.rs file. We could actually move this out to an audio.rs file. We're keeping it all in here just so you can see how this all looks. Let's move on to some collections. And the first collection we're going to look at is the vector, essentially a growable ordered list where every element is the same type. Let's write it here in our main function. Okay, let's run that. Open up my terminal that I had before, get some real estate going, run that, and there we go. So we've printed out 10, 20, 30, and then also this out of range right here. So let's actually examine the code that we've written. So we create one by using this vec : new, and we push values into the vector. If you already know what's going in, we can reach for the vec macro, and that's essentially a vector exclamation with your values in square brackets. Now, to loop over this collection, we're essentially writing this for loop, and we've got this ampersand scores where we're using to use as a reference. We're essentially borrowing the vector to read it. We're not taking it over. We're just reading all the values in there. So all the scores will still belong to the vector once the loop finishes. Now, take a look at get here. From our option lesson, you'll understand this particularly well if you've gone and seen that video. Essentially, this is handing back an option because the index 10 may not exist, whereas the index 10 does exist in our vector, But if we're searching a vector and we don't know what's in it, essentially we use an option to give us that safety that we talked about when we were discussing options. So when we print none, it will print out of range. All right, let's move on to our second collection, the string. Now, a Rust string is a growable heap allocated buffer of text, and it's encoded as UTF-8. So let's see it in action. Cool, I'm going to open up a terminal, use the existing one, just clear that. Actually, open up this terminal a little bit more, cargo run, and there's the output that we want. So printing out hello world, and then each character on each line. So let's see how that's happening in the code. So this push string method here that we're appending onto our string, essentially is just putting more text on the end. So our original string is hello, and then we're appending that with this comma and world there to make hello world. Now the format macro that we're using here builds a brand new string out of pieces, and it works just like printline, except instead of printing, it hands you the finished string back to you. Now, this is where strings can get a little quirky. A Rust string, like I mentioned, is UTF-8. So a single character that you can see on screen can take up to more than 1 byte in memory. And because of that, Rust won't let you grab a character by a plain number, since that number could smack in the middle of another number. So instead, you step through the string over characters when you want whole characters. And this is exactly what we're doing here. Or over the bytes when it's the raw bytes you're after. And finally, let's take a look at HashMap. Now, a HashMap stores keys paired with values. So we'll write one out and then we'll explain how it works after we've done that. Let me open up a terminal and run it. And we can see our hash map with its key and value. So we'll get out of that and we'll walk through this code. Okay, so we create our new hash map. We're creating a new hash map called inventory by just calling hashmap : new. We can then insert items into the hash map using insert. So we've got a key value of apples and a value of 12. And we can actually use the get method here to retrieve apples from our hash map. And then you can insert into the hash map using this entry method. So here we're inserting the pairs key into that hash map. Cool, now let's move on to error handling. So Rust draws a really clear line between two different kinds of failure. The first is just a bug, and this is where your code is just wrong, so an assumption that you made in your code didn't hold, and for that we panic, and the program stops with a message. The second kind is a little bit different. This is a failure that we do expect, so a file might not be there, some input that's malformed. Your code is fine here, but the environment that your code was operating in just didn't cooperate with you. And for that, we have a result. And now whoever called you, you have to deal with both outcomes, either the success or the failure of that result. And that distinction right there is really the heart of error handling in Rust. So the result is just an enum-like option, and it has two variants, either OK, which carries our success value, and error, which carries whatever it was that went wrong. So let's look at that opening a file example. That's a really good example to take because the file might not exist. So what I'm going to do is just get out of that, and I'm going to write the following. Okay, let me open up the terminal again. I'll just clear that and we'll run it. Cool, so we've got our could not open the file. So it's looked in that directory and there's no, just get a little tiny bit more real estate, there's no hello.txt file there. So it's not gonna open the file. But our application hasn't crashed, it's just returned this error message to us. So like I said, there's no hello text file sitting there, which means we've landed in this error arm, and we print our message and the program just carries on. There's no crash, nothing fails over. Now, if a missing file was really fatal for us, we could instead go and panic in that arm instead. But most of the time, we'd rather handle it and just keep going. There is a much cleaner way to do that than writing out a match like this every single time. And that's the question mark operator. So matching on every single result by hand, that can get really old really quickly, especially if you've got a few of them in a row. So what Rust does, it actually provides us with a shortcut, and that's the question mark operator. You put a question mark after a call that returns a result. If that call worked, great, you get the value straight out, unwrapped, ready to use. But if it failed, the question mark immediately returns that error out of your entire function right there and then. So the caller deals with it and you never have to write that match yourself. Let me get out of the terminal and I'll show you an example. Okay, let me open up a terminal and cargo run. And could not read the username is our output. Now if I just close that and we'll go over the code. So this question mark, essentially if this failed, essentially what it's saying is bail out and pass the error back. Otherwise, go ahead and give me the value that's in our OK statement. So here, this read to string method can't find username.txt. I'll open up my file directory. There's no text file there. It's called username.txt. So that error is going to shoot straight out of read username. And it's the main method where we're actually calling this read username in the match statement that ends up reporting it. Now there is one catch, and this is important to note. The read username itself returns a result, because the question mark only works inside a function that already returns a result. So and it needs to send that error somewhere. So you can't just drop it anywhere you like. So it's really important to note that. Okay, let's recap because there was a lot of content in that video. So let's go over the main points. We first took a look at modules, and modules help organize a growing code base. In Rust, we split our code into modules, and we can use the keyword pub to control what's visible from the outside, pub being public, and use pool names in so we're not writing full paths everywhere. Then we took a look at collections, so we looked at vectors, strings, and hash maps, and these are everyday containers. A vector is a growable list, a string is growable text, and a hash map maps keys to values. And most of the data that we touch inside Rust will fit one of these three collections. We then took a look at error handling, and we took a look at panic versus result. Now, panic is for the bugs that should be impossible, and those will actually stop the program. Result is for failures that we expect. These are things like a missing file, and it makes the caller able to respond. And when you're not sure between panic and result, it's almost always result. And then finally, we took a look at the question mark notation, which helps clear up error handling. It means if this failed, return the error. Otherwise, just give me the value. And this is really handy because then we don't have to have massive amounts of nested matches as long as our function returns the result. Now in our next episode, we're going to build our second project. We're going to build a small interpreter all the way from raw source text through to actually running it. And we'll kick that off by turning text into tokens and grow it out into a syntax tree. It's going to be a really meaty project, so if you like this video, give it a like. Please rewatch it if any of these concepts aren't concrete in your mind. If you want to catch all of the Rust videos as part of this series, make sure you subscribe. If you have any questions, please put them in the comment section below, and please check out the description for all the resources that are relevant to this video. I'll see you in the next one. Thank you so much for watching, and we'll kick off our next project in the next video.